These are the rocket motors we normally build. But today, we're going to be building this rocket motor. Now, I can't take credit for this motor design. This motor was developed by Dan Pollino, and this is Dan's K500 motor. I do want to take a moment to thank Dan for his hard work and dedication in the field of amateur rocketry. He's been a great help to people all around the world trying to learn about rockets and rocket motors. I did a short interview with Dan a little while back. There's a video on our channel about that if you want to learn more about Dan. Take a look at that video. There's a link down in the description, and I'll also put a link to his YouTube channel down there as well. Now, we're going to be following Dan's instructions very closely for building this motor. Now, before somebody asks,
can you send me a copy of those instructions?
Well, the short answer is no. Let me explain. See, a few years back, Dan wrote a couple of books about making rocket motors and rockets, and the information we're going to be following is from his book called I Still Have All My Fingers. And because that's copyrighted material, I can't distribute it. We're going to be going through every single step of the building process for this motor. Now, a little look into the future. If this motor test goes well, I'm going to need to build a rocket to launch this, a big rocket. So if you're not subscribed to the channel, hit that subscribe button and don't miss out on any of our future content. And hey, while you got a second, hit that like button. We really appreciate it. Let's go build a motor. Here's the stuff we're going to need to build the nozzle. Let's take a closer look at each item. First, we just have a 2-inch PVC coupling, and then we have a short length of 2-inch Schedule 40 PVC pipe. Now, the length of this isn't really important because we're only going to be using a couple of inches off of one end, but we are going to be drilling some holes in this, so we want a length long enough so that we can hold it while we're drilling those holes. And for those holes, we're going to be using a 1/2-inch drill bit. I will start out with a smaller drill bit just to drill the pilot holes before drilling the holes out to 1/2-inch diameter. And then we'll need some PVC cement. I'm going to be using this red hot blue glue. Now, the nice thing about this is you don't need PVC primer for that, but if you want to just use PVC primer and regular PVC cement, that would work fine too. And then we have the nozzle washer. Now, the dimensions of this washer are very important, specifically the inside diameter. Now, this is technically a 7/8 washer, but it's not your standard size 7/8 washer. I'll put a link down in the description to a website where you can actually purchase the correct washer. I wasn't able to find the exact washer I needed at my local hardware store, but I was able to find one that had the proper outside diameter with a smaller inside hole, so I simply bored it out to the size I need. Now, what we need is an inside hole diameter of 0.906 of an inch. We want an outside diameter of 1.75 inches. And the thickness isn't really that important. You just want a nice thick washer. You don't want to use one of those thin fender washers. This one happens to be 0.13 of an inch thick. And then we need some anchoring cement. Now, you don't necessarily need to use this brand, but I do highly recommend that you use anchoring cement. Now, on some of my smaller motor builds, I've had people ask me, can I use something other than anchoring cement? Usually they're asking if they can use Portland cement because it's readily available. Now, on my smaller motors, I don't have a problem substituting out with Portland cement, but this is a very big high power motor, and I really recommend anchoring cement for this project. Now, the reason for anchoring cement is that anchoring cement does not shrink as it dries. So you don't need to use this brand, but I highly recommend anchoring cement. Now, then we've also got a mixing cup and a mixing spoon. We'll need some water as well to mix up that anchoring cement. And here I have a step drill. Now, when Dan was making his motors, he used a taper drill. You see this one kind of has individual steps where it gets bigger as it goes. A taper drill bit looks exactly like this, except it's smooth all the way up the side instead of having these steps. Unfortunately, that taper drill bit is about $70, and I really didn't want to buy one just for this project. So the step drill will work just fine for our needs as well. This is so we can drill the convergent angle in the top of the nozzle, and you'll see that a little bit later. And lastly, we have 4 templates that we've printed out. Now, even if you manage to find one of Dan's books for sale online, it doesn't come with the templates. The templates had to be downloaded from his website, and the website no longer exists, so there's no way to get a hold of the templates. But I'll give you all the information you need to either reproduce these or to do the project without the templates. This first one is the one for drilling the 8 half-inch diameter holes. Now I'm going to show you an alternative method to using the template, so we're not actually going to need that particular one. The second one is for drilling 4 small holes for some little metal inserts. Now when Dan was holding his motor into his rocket, he had 4 little metal inserts around the bottom of the nozzle area that he could run screws through the rocket and into the motor to retain it in. Now we're not going to do this particular template and insert the inserts for mounting the motor for a couple reasons. Number one, this is just a test motor. We're not actually going to install it in a rocket, so there's no need to install these mounting points. And number two, I haven't actually decided when I get to mounting this motor into my rocket how I'm going to install it. So we may do this system, but I'm probably going to do a different system for attaching the motor into the rocket. This next one is just a small rectangular piece. I'll give you the dimensions of that because we will be using that a little bit later. This last template is just a round circle with a slot cut up all the way to the center. We will be using that as well, and we'll get to the dimensions of that a little bit later. And we'll also need some clear tape to go along with those templates. And then we'll need some basic shop tools for drilling and cutting, and you'll see those as we get to them. So let's get building. The first thing we need to do is we need a 1/2 inch long piece of our PVC pipe. So we want to start out with a nice straight cut across the top. Let's take this over to the saw and cut off a 1/2 inch length of this pipe. Now I'm going to be using the radial arm saw for this, but you could also use a band saw or a miter saw. Now we need our first template. Now this one is just a circle. It's 203 millimeters in diameter. Then you find the exact center and cut a slit from one edge all the way up to the center. So what we want to do is roll this up like that. We're trying to keep the bottom surface as even as possible and just keep rolling it until we get it small enough so that it fits into that little piece of PVC pipe that we cut. Alright, so now we have it just a little bit smaller than the pipe. If we put it into that piece and let go, it will just expand to the size of that pipe. Then we want to take a small piece of tape and just get this edge closed here and put a piece of tape right down that edge, and then it will hold that shape. Now we just want to line the whole thing with the clear tape. We're basically making it waterproof. Now it's not important to go all the way up to the top. We can start about 1/2 inch or 3/4 of an inch from the top. So we'll just start at the seam. Place a piece of tape on like that, and we'll keep laying pieces of tape slightly overlapping each one until we get the entire piece wrapped with tape. Alright, so the whole piece is wrapped in tape except for the top 1/2 or 3/4 of an inch where it's not needed. The tape is just overhanging here. We'll just use scissors to cut off that excess tape. There's our finished cone. We can set these pieces aside and move on to the next part. We're going to need that 2-inch PVC pipe, and this is where we're going to be looking at this template here that shows us where the 8 1/2 inch diameter holes are located. Now the exact positioning of these 8 holes is not extremely critical. They just have to be basically in the right place. The purpose of the holes is so that when you're pouring the anchoring cement into the nozzle, it has some spots for the anchoring cement to go into these holes, and allow it to grab onto the PVC rather than the nozzle just shooting out through the PVC if it was smooth. So I'm going to show you a technique for positioning these holes without using the template. So the first thing we need to do is, again, we want a nice straight cut across the PVC, and we're going to make a mark right at the top of the PVC here. And then we're just going to go straight down, eyeballing this as best we can to the opposite side. Rotate that 90 degrees, make another mark right at the top and another one right at the bottom. So we have 4 marks in a plus sign. Now we just want to make 4 more marks in between those. So again, just eyeballing it as best we can for accuracy. And there we have our 8 marks. Now we want to make some lines on the side of the PVC pipe going down from each one of those 8 marks. Now it's easiest to have a nice little block of wood. This is just a 3/4 inch piece of MDF, because if you lay this on the side like that, it gives you a nice straight area where you can mark those lines. So I'm just going to use this and roll the pipe around to each one of those lines and make a mark down the side of the PVC. The length isn't really important. It needs to be at least 1 inch or about 25 millimeters. So I'll repeat that for all 8 of those marks. And here you see I've got all 8 of those lines marked on the pipe. Now 4 of these holes are going to have the center of the hole 10 millimeters down from the top of the pipe. And the other 4, the centers of those holes will be 25 millimeters down from the top of the pipe. So I'll just use my ruler here, and we'll start at one of these, and we'll just make a mark 10 millimeters down. Then for the next one, we'll make a mark 25 millimeters down. And then 10 millimeters and 25 millimeters. And we'll repeat that until we get all the way around. Now that we have all 8 of those points marked, we'll head over to the drill press. Now in Dan's instructions, he uses a Forstner drill bit to drill these 1/2 inch diameter holes in the PVC. And that type of drill bit would probably make drilling these holes a little bit easier, but we're just going to use standard high-speed drill bits. And to make it a little bit easier to get that 1/2 inch diameter hole, we're going to start out by drilling some 3/16 diameter holes first. Once all the pilot holes are done, we'll switch out to the 1/2 inch drill bit. So I'll be perfectly honest with you guys, sometimes things don't go according to plan. The drill bit grabbed onto the PVC so hard that it snapped the PVC. So I'm going to cut this off and remark it and start over, but instead I'm going to start off with the 3/16 hole, and I'm going to keep enlarging that a couple of sizes each time until we get to the 1/2 inch diameter that we want. Alright, so got a little bit of a shorter piece here because we cut off that end. I've marked all those and pre-drilled them with the 3/16 bit. I'm going to increase this by 1/16 of an inch until we finally get up to the 1/2 inch diameter that we want. Now that is probably why Dan used the Forstner bit, because it wouldn't have grabbed on so violently and snapped the plastic like the 1/2 inch high-speed drill did. Alright, so that's done. Now it did take a lot longer than I expected, but it did come out nice. Now the real trick there was to drill every single hole extremely slowly so that the drill bit didn't have a chance to bite into the PVC and tear it apart. I think if I'm going to ever build this again, I'm going to go ahead and buy a Forstner bit, and hopefully that works a lot better in this situation. Now we just need to cut this down to the proper length. So we're going to measure down from the top of the pipe here 66 millimeters and make a little mark. and that's where we need to cut it on the saw. Alright, so that piece is done. I went around and cleaned up any loose PVC shavings around the holes, and we're ready to glue that into our PVC coupling. And we're going to glue the end with the holes into the coupling like that. So we'll be using our PVC cement. Again, if you're using standard PVC cement, you'll want to prime this first. This one does not require primer. And press that in, and also give it about 1/4 of a turn. And then we'll just let that sit for about 30 seconds while that glue sets up. Now this next step is something we're not actually going to do on this build, but I did want to show it to you because it is part of the instructions. And it involves installing 4 threaded inserts into the nozzle that are used to attach the rocket to the motor. Now we're not doing that on this build because this is just a test motor, so we don't have a rocket to attach to. And those inserts are really a specific method for attaching the rocket to the motor, which you may or may not use, and I haven't decided how I want to hold this particular motor into the rocket because there's a lot of different techniques. So this may be something you would want to do on this motor, or you may need to do something different to hold your motor into your rocket. So it involves this template. There's 4 holes that need to get drilled. They're 5/16 diameter holes, and they get drilled 15 millimeters up from this edge of the coupling. So if we mark up from that edge 15 millimeters, that's where the center of the holes would be. Now the positioning of these holes is actually quite important because we don't want to interfere with the holes that are already drilled in the piece of pipe inside. So we can still see these lines that stick out the bottom of the pipe that tell us exactly where those holes are. Let me just illustrate with a couple of these. So here there's a hole that's up high. Here there's a hole that's down low. And here there's another hole that's down low. The position of these 5/16 diameter holes needs to go in between these lower holes. So it would go right here. And again, you would measure up 15 millimeters from the bottom of the coupling. And so that would be the location of one of the 5/16 diameter holes in between these 2 lower holes. And you would have 4 around there. Those inserts get pressed in. I'll show you a picture of those inserts here on the screen. And then once they're installed, you install 1/4 inch screws into those inserts just to plug the holes. And that way when you're pouring the anchoring cement into the nozzle, it doesn't come pouring out of those inserts. The screws are then removed later so that you can attach the motor to the rocket. So now we're going to get ready to actually pour the anchoring cement and form the nozzle. Here we have our last template. This is the nozzle throat template. It's just a rectangular piece of paper, and it is 152 millimeters wide by 25 millimeters tall. This one's real simple. We just need to roll this up, and we need to roll it small enough so that it fits into the inside hole of our nozzle washer. Just make it a little smaller, plop it in there, and then let it expand so that it fills the hole. And we just need to put a small piece of tape on the end just to hold that shape. Once that's on there, we'll take a longer piece of tape and just put it along the entire bottom edge of that paper roll, just to make that waterproof so that it won't get soaked by the anchoring cement. Now, if it happens to hang over a little bit because it didn't go on straight, we'll just use the scissors to cut off the excess tape. Now we need our nozzle and the cone that we made earlier. We'll just place the nozzle washer on top of that cone, get it nice and level, place the PVC pipe portion of the nozzle over the cone and press it gently down onto the table. And then we just need to take the little ring of paper that we made and position that so that it goes into the center hole of the washer, just like that. Now we're ready to mix up the anchoring cement, but before we do that, we need to go over a couple of details, because as soon as we mix that up, the clock is ticking and we really only have a few minutes of working time before that starts setting up. So first off, how much anchoring cement are we going to put in there? Well, here's another coupling for an example. You see down in the coupling, there is this little ridge halfway down. We're going to put anchoring cement into the nozzle until we just bury that ridge. Now be sure to read the instructions for your particular brand of anchoring cement if you're not using this one. Now for this one, we're looking for a consistency around pancake batter. We want it to be liquidy enough so that it pours nicely around the washer. If it's too thick, it won't pour around and settle into the bottom of the nozzle very well. So in the instructions, it says to mix together the anchoring cement and the water in a Ziploc bag, mix that together, snip off the corner of the bag and use that to pour it into the nozzle. Now that technique probably works just fine, but I really prefer to use a mixing cup so that I can actually see the consistency of the product. If it's too thick, I can add some more water. If it's too thin, I can add some more anchoring cement. Now the instructions say that for one nozzle we need half a cup of anchoring cement, which I've already measured out, and we'll add to that 2 tablespoons of water plus 2 teaspoons of water. We'll go ahead and start with that mixture, and if it's too thin or too thick, we'll adjust it. But bear in mind, once you mix these products together, you only have a few minutes of working time before it starts hardening. All right, so to be honest, that's a lot more liquidy than I normally use for making nozzles. So I am going to add just a little bit more anchoring cement to that to thicken that up just a little bit. You really don't want to add too much at a time because it thickens up pretty quick. All right, I'm pretty happy with that. It's still a little bit more runny or liquidy than I normally would use, but it's much better than it was before. So in the instructions for this particular anchoring cement, they want you to let this sit for 1 minute after it's fully mixed, and then mix it one more time before pouring. So we'll wait 1 minute.
1 minute later.
All right, so we'll give it one more quick stir, and we're ready to pour. Now I'm gonna pour it kind of slow. We don't want to disturb any of the template or the washer that's in there. And I'm going to pour it around the edge of the washer because we want it to flow down all the way to the bottom. Now we might get a little that comes out along the bottom. That's okay. We should have plenty in here in case we lose a little bit out the bottom. Now here it's just gone past the washer. Before we finish pouring the rest of that in, I'm just going to give it a little tap just to make sure that there's no trapped air bubbles or anything in there. That helps the anchoring cement just kind of settle in place in case there are any air bubbles. They should come out. I didn't see any because I poured nice and slow, so looks good. We'll just pour just enough in here until we bury that little ring in the PVC coupling. There we go. I'll show you a close-up shot of that right here. Now we're just going to let that sit for 30 minutes. While we're waiting for that to harden, don't forget to clean out your mixing container. You need to clean that out within about 5 or 10 minutes or it's going to completely harden in the container. So just a quick update on mixing the anchoring cement. If I had to do that again, I would still start out with half a cup of anchoring cement, but I would start by only adding 2 tablespoons of water, and then just add more water as needed to get it to a good pourable consistency. Now that that anchoring cement has had some time to set up, we can pull out the paper cone. And the paper ring at the top. Now the last thing we need to do to finish this nozzle is to use our step drill or bevel drill to simply drill the convergence side inside the coupling end here, just to give it a little bit of a taper. But I don't want to do that just yet. With only 30 minutes of dry time, the anchoring cement is set, but it's not completely hard, so I don't want to drill into mushy anchoring cement. So we'll give that at least another hour or so to harden, or you could let it harden overnight, and then we'll drill that bevel.
1 hour later.
All right, so I'm ready to drill that bevel here. Now, one thing I want to be careful of is I don't want the drill bit to go down and hit the washer, because there's a chance that you could grab onto that washer and spin it inside of the concrete, and that would be really bad. So I'm going to be real careful just to drill a gentle bevel, but not enough to actually come in contact with the washer. All right, that came out really nice. Now, the step drill did leave a little bit of a step inside there. So I took a 1/4 round file and I just went around real gently and just cleaned up that beveled area. We ended up with a really nice looking bevel in there. So this nozzle is done. We're ready to move on to the next step. Next, we're going to make the igniter. Now let's take a look at the parts we're going to need. First, I've just got a small piece of 1-inch Schedule 40 PVC pipe. It's been cut 1 inch long. And then we'll need some tape. You can either use duct tape or masking tape. And then I have an E-match. This is just a little device that makes a small flame when power is applied. A 1/8 drill bit and a drill to go along with that. We'll also need a multimeter, and that's just to make sure that the E-match is good. We'll also need some 5-minute 2-part epoxy. Now we're also going to need to make a powdered fuel mixture to go in this, but we'll get to that after we build this part. Now we're going to be deviating a little bit from Dan's instructions on this part of the project. Dan didn't use an E-match. Instead, he drilled 2 small holes through the pipe, ran a piece of nichrome wire through there, and when you apply electricity to the nichrome wire, it lights on fire and ignites the small amount of fuel that's inside the pipe. Instead, we're going to be using these E-matches. They're readily available, inexpensive, and they're pretty dependable. We have a lot of these on hand because we use these for igniting our smaller motors and our ejection charges. But before we install that, we need to verify that the igniter is good. To test the igniter, we're going to use our multimeter. First thing I'm going to do is just remove this plastic cap because we're not going to need that. And then untwist the wires so that they're separated. Now, if you've got a diode setting, you can use the diode setting and check continuity across. It shouldn't just make a constant beep sound. If you don't have a diode setting, you can go to your ohm setting and check the resistance across those leads. It should be somewhere around 1 ohm. Now I'm going to drill a small hole in the side of the PVC pipe with the 1/8 inch drill bit. Now you can do this on the drill press or with a hand drill, it doesn't matter. It just needs to be about 1/8 of an inch down from one end. Just like that. Now I'll take my igniter, I'm going to twist those wires back together, and I'm going to feed that into the hole we just drilled from the inside of the pipe to the outside so that the little igniter is inside the pipe. Next, I'll take a small piece of tape, lay it down sticky side up, and place the PVC pipe right down on the center of that tape. Put the igniter on the bottom of the pipe. I'm just going to cut off the excess tape because we don't need a lot. We just want a little bit sticking out around the PVC pipe like that. And then we can just wrap that up around onto the side of the pipe. Now, just to make sure that this doesn't come off while we're working on the project, we'll wrap another piece of tape. It doesn't have to be quite as wide as that. We can rip that down a little narrower like that, and just put that all around the pipe like that to hold that piece of tape on the top nice and firm. Now that that part is done, we're going to need some powdered fuel to put in there. So let's take a look at what we're going to need. We'll need some powdered sugar. This is available at just about any grocery store. And then we're going to need some potassium nitrate. Now, this could be either powder or granule. It doesn't matter because we're going to grind this up anyways. This one that I have is already in the powdered form. And to grind that up to even a finer powder, we're going to need a small blender. This is a coffee grinder. You can use a small blender or a coffee grinder. The coffee grinder just seems to work a little bit better as far as making a very fine powder. If you have settings on your coffee grinder, you'll want to set it to the finest setting. Then we'll need a small gram scale. Now if your gram scale goes down to 1/10 of a gram, that's great. If it only goes down to 1 gram, you'll still be able to do this. But I like the 1/10 of a gram scales because they're a little more accurate for smaller measurements like this. And then you'll need a small container with a lid to mix the ingredients together. If you're going to be storing this long term, you're going to want a container that's also airtight. This fuel mixture is a 65-35 ratio, so it's 65% potassium nitrate and 35% powdered sugar. Now we don't need much because we just need enough to fill that little PVC pipe. So if we use 26 grams of potassium nitrate and 14 grams of powdered sugar, we should have enough to make this igniter. Now even though I only need 26 grams of potassium nitrate, I'm going to measure off a little extra and grind up about 36 grams because we're going to lose a little bit in the coffee grinder. Some of it sticks to the lid or gets stuck in the mechanism. So we want 26 grams when we finally mix the two products together. So I'll grind a little bit extra. And because we're using such a small amount, we can grind the whole thing all at once. And we'll just grind this for a minute or two until we get a really super fine powder. If you want to see about how fine you want to get it, just take a look at the powdered sugar. That's about how fine we want to get the potassium nitrate. Now before we add the sugar to the potassium nitrate, we want to do one more thing. We're going to bake this in an oven at 300 degrees Fahrenheit for 30 minutes. The reason we're doing that is because potassium nitrate is hygroscopic, which means it absorbs moisture from the air. So we're going to be baking it to pull that moisture out of the potassium nitrate to make it as dry as possible. Do not put this in an air fryer or an oven with a fan. It will blow this all over the place. 30 minutes. Now we'll measure 26 grams of potassium nitrate, and then I'll add to that the 14 grams of powdered sugar. Now remember, once you mix these two ingredients together, this is now flammable. So never put this back in the oven. Keep it away from open flame or any kind of ignition source. We're just going to shake it up for about a minute or so just to get those two ingredients very well mixed. Now I'm going to fill the little PVC pipe with the igniter in it. And we're just going to put a little bit in and we'll tamp it down a little at a time. We don't want to fill it all the way because we want it nice and packed. So we'll just put a little bit in, and you can either tamp it down with a little tool or with your finger. And we'll just keep adding a little bit at a time and packing it down until it's all the way to the top. And then when we get all the way to the top, you'll find that if you use a spoon, or this is a ½ teaspoon measuring spoon, you can just use the bottom of that to make a little concave area in the top of the powdered fuel, and then just clean off the top area of the PVC. We're going to be putting some epoxy on here, so we want this little indentation to fill up with epoxy, and then we also want the epoxy to stick to the side of the PVC here. So we want that to be clear of any powdered fuel. I measured the amount of fuel mixture that was left over, and it looks like we took about half to do one igniter. So this is enough to make 2 igniters, or just cut the recipe in half to make 1. Now we're ready to fill this top with 2-part epoxy. So I'm just going to mix up a small amount of the 2-part epoxy. Follow the instructions that come with your epoxy, but usually you mix this for about 45 seconds to a minute. And then I'm just going to gently lay that in to the concave area on top of the fuel. You don't want to disturb the fuel. And then spread it out so that it comes in contact with the top edge of the PVC pipe. That way it will completely seal that fuel in place. And there's the last little bit. That's completely sealed in. And we'll let this sit for about 15 minutes. Now, if you're noticing some of the dry fuel come out around where the wire comes out on the side, you could take a little bit of this epoxy and just put it around where that wire comes out just to seal that area. We are almost ready to make the fuel for this motor, but first we need a couple things to make the core hole in the fuel. First thing we'll need is a coring rod, and this is a monster of a coring rod. It is a 1-inch solid aluminum rod, 50 inches long. We need to do a couple things to this to get it ready. First, I took it over to the bench grinder and I made a nice rounded end on one end of the rod. And then I took some 220 grit sandpaper and just sanded that rounded end. It was a little bit rough from the bench grinder. I also used that same 220 grit sandpaper to sand the entire length of the rod just to get out any small dents and defects. You want this rod to be as smooth as possible. And finally, I drilled a 1/4 inch diameter hole a little bit down from the flat end. Now hopefully that 1/4 inch hole isn't going to be necessary, but I figured it was just a good idea. In case the rod gets stuck, we can stick a screwdriver in through there for a little extra leverage to be able to turn the rod or pull it out. So hopefully we're not going to need that, but it's there just in case. Next we need to build a core rod alignment tool. Here's the parts. First we've got a 2-inch PVC coupling, and then we have a 2-inch to 1-inch PVC adapter, and then a 12-inch long piece of Schedule 40 PVC pipe. Now these just go together like this. The adapter goes into the coupling and then the pipe goes into the adapter. And this is all going to be glued together with our PVC cement. Now this PVC coupling needs to fit nicely onto a piece of 2-inch PVC pipe. That's going to be the top of our motor casing. But like any other PVC fitting, it gets tight and it doesn't slide all the way down. This isn't going to be glued in place. This is just going to be placed on top of the motor while we pour the fuel. So the solution to that is we need to increase the inside diameter of the coupling. Now the instructions tell us that we can take a 2 3/8 inch hole saw, put that in the drill press and drill down into the coupling just until we've removed that little ring at the center of the coupling. But I don't have a 2 3/8 inch hole saw, so an alternative method would be to take a round file and simply file out that ring in the center and a little bit more material as well until we get it to slide nicely onto the 2-inch PVC pipe. So that's what I'm going to do. Alright, it's done. Now, I'll be honest with you guys, filing that out was a lot more work than I expected. It was very difficult. If I had to do this again, I would definitely buy the 2 3/8 hole drill. So the next thing we need to do is glue the bushing into the coupling. Now, because I used the file, and it's really kind of difficult to be careful with the file, you'll notice that this bushing no longer fits tightly in there. Now if I had used the 2 3/8 hole saw, I would have only drilled one side larger that fits on the pipe. The other side would still be tapered and this bushing would be tight in there. So even though it's loose, I think that will be okay as far as getting it glued in place. So I'm gonna put down a paper towel here, and we're going to be using the red hot blue goo. Again, if you're using standard PVC cement, you'll need to prime these parts first, but this one does not need primer. Now, I'm only going to put glue on the bushing piece because if I put glue inside the coupling, when I push them together, there's just going to be a whole bunch of glue that's going to get pushed into the other side of the coupling. And because this side fits nicely onto the PVC pipe, I don't want to make a mess in there. So I'm going to put this coupling in this position and put glue on that, or PVC cement on that, trying not to get it all over my table. actually going to put a little more than I normally do because I know we're trying to fill a gap here between the two pieces. Place that like that, and then I'll push the coupling down onto that. I'll give it a little bit of a spin, holding the bushing in there. I'm just going to let that sit for a couple minutes, and hopefully those two pieces will bond together.
5 minutes later.
Alright, so I let that sit for about 5 minutes just to be sure that those two parts got bonded together well. Looks like it's just fine. And you see inside here, we don't have a mess of PVC glue. So the next thing we need to do is we need to glue on the PVC pipe. So simply put a little bit of glue on that and put that in place. Make sure it gets seated all the way down and hold that in place for about 30 seconds. And there's our finished core rod alignment tool. Now we need a length of 2-inch Schedule 40 PVC pipe. This is going to be the main body of the motor. It needs to be at least 35 inches long. We need to start out by cutting a nice straight cut on one end. And then from that end that we just cut, we'll measure down and put a mark at 31 3/4 of an inch and 35 inches. And then we'll take this back over to the saw and cut it at the 35-inch mark. So just a little note about cutting this piece of pipe on this type of saw. I can't actually cut this on here because as I bring the blade across, the bottom of the motor is going to hit this section of the pipe that I'm trying to cut off, just because there's not enough space under here. So I'm going to take this over to the bench and cut it with a hacksaw about 1/2 inch longer than the 35-inch mark, and then I'll come over here and just cut off that last 1/2 inch just so I get a nice straight cut. All set. So if you're using a band saw or a miter saw, you wouldn't have to do that extra step because you'd be able to cut it right at the 35-inch mark the first time. Now we're going to glue this pipe to our nozzle. Now here's the end where we had the mark at 31 3/4 of an inch. We're not going to glue that end to the nozzle. We're going to glue the other end to the nozzle. We'll be using our PVC cement. Now this one doesn't require primer. If you're using standard PVC cement, you should prime both parts and then glue it together. And when you put it together, give it a 1/4 of a turn and hold that for about 30 seconds. Now this next step is not in the instructions, but I think it's extremely important. So right here I have the motor casing with the nozzle at the bottom. If we take our core rod alignment tool, place that onto the casing, and then we'll insert the core rod. And we want to be sure that the core rod goes all the way down and seats right in the center of the nozzle. And we can check that simply by feeling up inside the nozzle, and I can feel the rounded end of the core rod in there. So what we want to do now is take a marker and make a mark all the way around the rod at the top of the alignment tool. So if we pull that out, you see we've got a line on the rod here. That's very important because when we're coring the fuel, it's going to be very hard to feel when the rod is seated. So we need to get the rod all the way down to this point so that line is right at the top of the alignment tool. If it's not there, it means that the rod is not fully inserted and not seated into the nozzle. If we let the fuel harden with the rod in the wrong position, this entire motor is trash. So very important to have that mark and make sure that we get to that point when we core the fuel. And now the fuel ingredients. Now this is a sugar fuel called flexi-fuel, and we're going to need 1,540 grams of powdered potassium nitrate. It's best to purchase this already in the powdered form. And we're not going to be grinding this up into a super fine powder like we did for the igniter. We're just going to be using it in the standard powdered form. Now there's 3 times in this project where we need potassium nitrate: the igniter, the fuel, and the smoke element. And each time we want to make sure that it's as dry as possible. And that's why we heat it in the oven at 300 degrees Fahrenheit for 30 minutes. But you don't have to do that 3 separate times. It would be a really good idea to measure out about 4 pounds or around 1,800 grams of potassium nitrate at the beginning of the project, heat that in an oven, and then after that's done, just transfer it into an airtight sealed container. And that will be plenty of potassium nitrate for the entire project. And you'll only have to run the oven once. Next, we need 426 grams of powdered sugar. And the final ingredient is 403 grams of corn syrup. And now the equipment we're going to need to make the fuel. First off, some safety equipment, just some gloves and safety glasses. And then we're going to need some WD-40 or similar product to spray the coring rod so it doesn't stick to the fuel. We'll need an infrared thermometer to check the temperature of the fuel. Now in Dan's instructions, he shows another option. You can use temperature sensitive stickers. You would stick one of those stickers onto your stirring spoon, and as you're stirring the fuel, the sticker would turn black when it reaches 210 degrees Fahrenheit. The problem I have with that is the sticker is going to turn black as soon as it hits any portion of the fuel that reaches 210 degrees. So definitely recommend an infrared thermometer. And then a scale so that we can measure out our fuel components. A mixing bowl and some mixing spoons. I've just got a variety of spoons and spatulas here just so we have everything we need. And then something I bought just for this project, a brand new electric wok. So when we normally cook our small batches of fuel for our smaller motors, we just put that in a saucepan and heat it over a small electric cooktop. But that doesn't work very well for a large volume of fuel because it's really hard to heat up a large amount of fuel in the saucepan and get it consistent. The wok has a much larger cooking surface, so this is what Dan uses in his instructions, and I'm really excited to use this for the very first time in this project. And then lastly, we're going to need a wide mouth funnel. Now, you can't use a standard funnel like this because the fuel just won't go through this small diameter. Now, you could take a funnel like this and simply cut it so that it stops at a much larger diameter, something that would fit nicely into the top of the motor casing. But I'm actually going to build a funnel using a half-gallon milk jug. To make the funnel, I cut off the top section of the half-gallon milk jug. And this would work fine the way it is, except it's very lightweight, and be afraid that as you're pouring the fuel in here, it could move around or even fall out of place. So I cut a 1-inch long piece of Schedule 40 1.5" PVC pipe, and that pops onto the bottom of the jug just like that. Now that holds very well, and it adds some weight and makes that stay in place very nicely, but I'm actually a little bit afraid that as this heats up when you pour the fuel in, that this could possibly fall off and fall into the motor, and that would be really bad. So I'm just going to use some adhesive to glue that in place. You could use construction adhesive or caulking or anything like that. We'll just put a little bit around the base here of the snout of the container, and we'll just stick that in place and spread that around. We'll give that several hours to dry. All right, we're set up here on the workbench because you're going to need a lot of space to spread out to make and pour the fuel. I've got my safety glasses and gloves over here. Right in the center, we've got the cooking wok and the infrared thermometer, as well as some spoons and spatulas to mix the fuel. Over here, I've got the dry ingredients. They're already mixed together, very well mixed. I haven't measured out the corn syrup yet. We'll get to the ingredients in just a moment. Over here I've got the core rod centering tool and the spray oil, our funnel, and sitting down on the floor is the motor. Alright, and back here we've got the coring rod set up on some paper towels so that when we spray it with the spray oil we don't make a complete mess. Now it's a little chilly in the garage today, so the coring rod is a little bit cold. And this step isn't in the instructions, but I think it's a good idea. I'm going to take an electric heating pad and I'm just going to wrap it around the bottom section of the coring rod so that this will be warming up a little bit while we make the fuel. I've seen in the past with smaller coring rods where trying to insert a very cold coring rod into the fuel makes the fuel cool down very quickly, and it can be difficult to get the coring rod fully inserted. So this will just warm the bottom section of the coring rod just a little bit and hopefully make it a little bit easier to get it fully installed. Now, it's a good idea to hold the motor in place in some way, just so while you're pouring the fuel in, it doesn't accidentally fall over. I've cut out this little ring here. I'm just going to put that around the top of the motor and clamp that to the table to hold it in place. You just don't want to do something around the body of the motor like a strap or a bracket that's applying pressure or force to the side of the PVC pipe. The PVC is going to get really hot when you pour the fuel in, and if you have something applying pressure to the pipe, it's probably going to bend it, and you're going to end up with a bent motor. So if you've got somebody that can hold this in place with a glove, that's fine. If not, just something to hold it on the top there just so it doesn't fall over. Now, one more thing we need to do before we pour the fuel into the motor. We don't want the fuel going down and filling the nozzle. So I've got a little piece of paper here, and this is just a small piece of 2-inch PVC pipe. This is the piece that we used earlier when we made the cone for the nozzle. We're just going to draw a circle on the inside of that, and then I'll cut that out. And then we're just going to drop that down into the motor, and we want to make sure that that goes all the way down and seats right on top of the nozzle. That will be the stop so the fuel won't go into the nozzle. Alright, so the last ingredient we need to measure out is the corn syrup. Now normally I would put my pan onto the scale and then pour the corn syrup directly into the pan. But the wok is a little bit heavy and it's too heavy for my little scale. So we're going to use a little bowl here to measure that out. Whatever you use, just use something that's got some nice rounded edges so that when you try to get all that corn syrup out, you'll be able to scrape that nicely and not leave any corn syrup behind in your measuring bowl. So we're going to measure out 403 grams of corn syrup. All right, the wok is still off, so it's still cold. We're going to pour the corn syrup into the wok. And again, we want to make sure that we get all of that poured in. Now, Dan's instructions say to turn the wok to its highest setting. We're just waiting for this to just barely start bubbling. All right, it's just come to a boil. We want to pour in all of the dry mixture. And then start stirring. You just want to stir constantly and get that completely mixed. It's going to take a while. Okay, this is fully mixed together. You want to stir non-stop so that you don't burn the fuel on the bottom. It's currently only about 135 to 140 degrees. We're looking for 210 degrees Fahrenheit. Hello, future me here. Now, I wanted to talk for a moment about that cooking process and specifically about the cooking temperature of 210 degrees Fahrenheit. I think in the end I ended up actually cooking that fuel to a much higher temperature than 210 degrees, even though I was trying to follow the instructions as close as possible. And that ended up making a harder fuel, which made installing the igniter a little bit more difficult. You'll see that in just a little bit in the video, and may have contributed to the problem that we had during testing of the motor, and you'll see that a little bit later in the video as well. So why is the cooking temperature so important? Well, a few years ago we did some testing where we cooked a couple of batches of fuel at 190 degrees Fahrenheit, 210 degrees Fahrenheit, and 230 degrees Fahrenheit. And what we found is each time when you increase the temperature of the fuel, your final fuel product becomes harder the higher you cooked it. But more importantly, the burn rate changes. There was a noticeable difference between the burn rate of 190 degree cooked fuel and 230 degree cooked fuel. The 190 degree fuel burnt a lot slower than 230. So it seems that the harder the fuel, the faster it burns. Now there's a couple things I think I would change about this cooking process, and we'll talk about those at the end of the video. So keep watching. All right, we've reached 210 degrees Fahrenheit. Now, I'm gonna have my cameraman come over here and just keep stirring this for me while I come back here. We'll get this heating pad off of the corn rod and just give this a nice liberal coat of spray oil. Just gently applying pressure down and spinning it just a little bit to help it go in. Remember, we've got our little black line here that we need to get this all the way down to that point. It's a little hard to spin here, so I'm going to use that hole that we made in the top just to get a little bit extra leverage. Okay, so I've got it all the way down. The black line is up just a little bit, but if I feel underneath here, I can feel the bottom of the coring rod poking through the nozzle, so that's good. Now it looks good now, and we're going to let this sit for 3 hours. Now cleanup is really easy with this type of sugar fuel. It's water soluble, so we're going to let the wok cool down a little bit, but all we need to do is just run that under some water and that fuel will completely dissolve, and the same thing for our tools. While we're waiting for that to cool, I just wanted to talk about a few things about that fuel making process. First of all, you should be in a well-ventilated area. It does put off some fumes and it does kind of smell. You really shouldn't cook rocket fuel in the house, and never cook sugar fuel over an open flame. That's extremely dangerous. It's also a really good idea to have a fire extinguisher nearby. Now, when I first started mixing the fuel up, I thought that I was going to be able to just pick the wok up and be able to scrape it myself into the rocket motor casing. But as I was stirring it together and realizing just how heavy this is, it's several pounds of fuel, I realized that was going to be a little difficult. So as you saw, I had my cameraman come around and hold the wok for me while I scraped it in.
3 hours later.
All right, I'm going to try and get this coring rod out. Let's see what we can do with just the screwdriver through here and holding the casing. Wow, that will not budge at all. But the problem is leverage. I can get a little bit of leverage up here with the screwdriver, but there's no real good way to hold on to the PVC pipe. Okay, so I got this idea of modifying the socket, and we'll go ahead and bolt that to the top of the coring rod, and we'll try attaching an impact wrench and see if we can get that to spin and loosen up. All right, so apparently Dan must have had a really good system for getting these out, because he says even though it's hard, you just put some pliers on here and work it out. This thing was ridiculously tight. I don't think we would have ever gotten it out by hand, but with this socket on here and just going real slow with the impact wrench and pulling, it's definitely coming out. All right, seems to be really easy now that we've got it a few inches out. All right. If we look down the core, we don't see any defects or pockets. That's good. So We're ready to move on. Let me show you a little bit more about the tool I made to be able to pull that core rod loose. I took an old socket and I put it on the lathe and I bored out the inside so that it was large enough to fit onto the 1-inch aluminum pipe. Now that wasn't completely necessary. I could have actually found a socket that was already big enough to fit on the pipe and just left the ridges inside there. I then took it over to the drill press and I drilled a hole all the way through the center there. And it's just a little bit bigger than a 1/4-inch diameter, just so there's a little slack there. And because I already had a 1/4-inch diameter hole drilled on the coring pipe, this allows me to simply put this on and put a bolt through. And then I could put the impact wrench on there and just turn this to break it free. That was way more difficult than I thought it would be. It seems like the resistance was just from the fuel that got packed up around the nose end of the coring rod, because as soon as we broke that loose and got the coring rod about 1/2 inch out, from there on it was easy to get out. So the next step is to simply clean up some of the fuel residue. We'll use some needle nose pliers just to clean up a little bit of fuel that's gotten into the nozzle area. And then we'll take this over to the saw and we're going to cut it off at that 31 3/4 inch mark that we made on the PVC pipe. Next we need to install the igniter. Now, the instructions tell us just to clean off any excess fuel that may be on the inside of the PVC pipe. This one is good and clean. And then if the surface of the fuel isn't flat, then we can just take a screwdriver and scrape the top of that fuel until it's flat. Well, there's a little problem there because this fuel is pretty hard. And based on the instructions, it looks like Dan's fuel was a little bit softer and a little bit more pliable than this. Now, since I do need a flat surface for the igniter to sit on, I'm just going to take a screwdriver and a little hammer and I'll just chisel away at the fuel surface until we get a flat area there where I can set the igniter on. Alright, so I've got a nice flat surface in there for the igniter to sit on. Now, before we glue the igniter in, we want to turn this over and come over to the nozzle end. We need to seal the nozzle end so that moisture from the air doesn't get into the fuel. Now, Dan was using some little vinyl plugs that fit very nicely into the nozzle. But if you just have some tape, I'm going to use duct tape just to cover that up. Fold that tape around, and then I'm just going to take a rubber band and put that around the edge just to hold that duct tape from coming off. And then we're ready to glue in the igniter. Now, the reason that we're going to glue the igniter in is because we want a nice solid seal between the igniter and the fuel. We're going to be pouring some epoxy resin in on top of the igniter, and we don't want that to ooze down around the igniter and get down into the core of the fuel. So we want that to be sealed. Now, Dan was just simply pushing the igniter into the fuel because his fuel was a little bit pliable and flexible. He was able to form a seal there. But because our fuel is a little bit harder and that surface is pretty uneven where I chiseled it out, we're going to actually just put a little dab of hot melt glue around the igniter and glue that in place to form a seal. Now, because you can't get your fingers in there with the igniter to hold it in place, you'll probably find it's easiest to hold onto the igniter with some needle nose pliers and drop it in that way. So I'll put a good bead of hot melt glue around the entire perimeter and place that straight down in the center. And then just press it in place and hold it there until that hot melt glue sets up. Now that the igniter is installed, we're ready to move on to the smoke element. Now the smoke element is just a slow burning product that's in the motor that produces a lot of smoke and allows you to track the rocket to a very high altitude because the motor will continue to produce smoke even after the fuel is gone. So let's take a look at the ingredients for the smoke element. The smoke element is made from 2-part epoxy and potassium nitrate. And we do need a super fine potassium nitrate powder, just like we used for the igniter. So we're going to grind that up in the coffee grinder. We need 86 grams of potassium nitrate, and that is going to be dried out in the oven at 300 degrees Fahrenheit for 30 minutes, just to drive out any moisture. We'll also need a disposable mixing cup and disposable mixing stick as well. Now the epoxy I'm using is a 2-part epoxy. This particular one is by Total Boat. Now when Dan was making his rocket motors, he was using a brand called West System. And the only reason I'm going with Total Boat is because this is about 30% cheaper. They're very similar products. They're both designed for marine applications, and they're both 5-to-1 mixture ratios, which means 5 parts resin and 1 part hardener. Now there is a slow hardener and a fast hardener. It doesn't really matter which one you go with. With the slow hardener, you'll typically have about 20 minutes of working time, and with the fast hardener, you'll have about 10 minutes of working time. Now the mixture for this is 65% potassium nitrate and 35% epoxy. Now we know we've got 86 grams of potassium nitrate, so if we do some quick math, that tells us that we need 46 grams of epoxy. The instructions tell us that if we're using the calibrated pumps, then we just need 2 pumps of the resin and 2 pumps of the hardener. So let's see exactly how much that actually gives us. Well, we got 45.9 grams. That's pretty close to 46 grams. So that's perfect. We'll go ahead and stir that up just for a moment, just to get those 2 products mixed together. And then we'll combine that with the 86 grams of potassium nitrate. Now this is going to be fairly thick. Now I'm going to pour it around the edge of the igniter, and it will eventually bury the igniter. And we want this igniter wire to be coming out around the center of the motor. So that came pretty close to the top of the PVC. We'll just position the igniter wire right around the center, and then we need to give that 2 hours to set up. So while we wait for that epoxy to harden, we need to prepare 2 more PVC parts. The first one is just this 2-inch slip coupling. Now, just like we did before when we were making the alignment tool, we need to remove the center ring inside here so that this coupling will slip onto a piece of 2-inch PVC pipe. It needs to slide all the way on, not tight, but also not loose. Now again, if you have a 2 3/8 inch diameter hole saw, you can simply put that in the drill press and drill down until you remove that center ring, and then this should slide nicely onto a piece of 2-inch PVC pipe. But I don't have a 2 3/8 inch hole saw, so I'm going to do what I did before and use a 1/4 round file and just simply file away until I've removed that center ring and it slides nicely onto the pipe. I ended up using a Dremel tool with a small grinding wheel on the end instead of the file, and that went a lot faster. And this slips on the pipe nice and snug. The next piece we need to work on is a 2-inch PVC slip cap. We'll also need a 7/32 drill bit. Now the instructions tell us that we need to drill 3 holes in the top of this cap. The first one is right in the center, but we're not going to drill the center one. The center hole was used for screwing in a 1/4 inch screw, 1 inch long, and it would stick up out of the cap just like that. This was a centering pin, so inside of Dan's rocket was a bulkhead where the motor would push up against that had a small hole in it, and the screw would go up through that hole to keep the motor centered inside the rocket. Now this is a test motor, so we don't need a centering pin, And depending on what design I end up using for our rocket, we may or may not need a centering pin on our design as well. So we're going to skip the centering hole, but I am going to make a little mark just with the Sharpie marker right in the center, just to illustrate where that hole would be. And then we need to drill 2 holes, one slightly to the left about 1/4 of an inch and one slightly to the right about 1/4 of an inch. Now we're ready to assemble these parts, and for that we'll need our PVC cement. So the first thing we need to do is slide the coupling onto the motor, and we'll slide that down about 6 inches down the pipe. And then the next few things we need to do kind of fast, because we need to glue 2 pieces in place, but we don't want the glue to start setting up while we're working on that. So first thing we need to do is just put a layer of PVC cement on the pipe, just a few inches down for the cap. And then we'll put some inside the cap. Slide this igniter wire through one of the holes in the cap. Place the cap in place, push it down nice and firm, and give it a little bit of a turn. And we'll let that set up just for a few seconds. And then we'll coat the pipe a couple of inches down, all the way around, just underneath the cap. We'll slide the coupling up and give that a little turn. We'll hold that for a few seconds while that sets up, and then we can clean off the mess. Now you might be wondering, why is there a PVC coupling there when it's not coupling anything together? Well, remember, the smoke element is inside the motor in this area, and the smoke element burns very hot and for a very long time. And it has a good possibility of actually burning through the PVC casing. So this gives us 2 layers of PVC all around the smoke element to help minimize the possibility of a burn through. Now we're almost done with this motor. The only thing we need to do is fill in the little air space underneath the cap with anchoring cement. The instructions tell us to use 1½ cups of anchoring cement and ½ cup of water. Now I don't really like mixing anchoring cement up that way because I think it's not very accurate. And I also think that 1½ cups of anchoring cement is probably a lot more than what we need for this project. So I've measured out just a little over ½ cup of anchoring cement, and I'm just going to slowly add water until we get the right consistency. Now before we mix this, we need to know how we're going to pour this into the motor. Now the instructions give us 2 options. One is we can simply just pour it into one of the small holes in the cap, but that's going to be very messy. A better option is to use one of these plastic syringes. So I'll go ahead and start mixing this anchoring cement until we get the right consistency. All right, that looks pretty good like that. So we'll just start installing that using the syringe. We just want to keep pumping that in until it comes out the other hole where the wire comes out. And there we go. Make sure you clean off your syringe if you want to use it again. Just clean off that excess. You just need to let that sit for at least 30 minutes for that anchoring cement to harden. And definitely that was a lot of extra anchoring cement. I probably only used maybe half or less than half of what we mixed up. So for this particular one, we could have probably only had about 1/4 cup of anchoring cement for the mix. This motor is done. Let's go test it. All right, it's a great day for a motor test. If I told you I wasn't nervous, I'd be lying. Let's see how this works. Well, that was very unfortunate, but not entirely unexpected. Now, this is a proven motor design. Dan has built and launched these many times. So what went wrong? Well, the answer is real simple. We overpressurized the case, but the solution is not quite as simple. So if I assume that I made the nozzle with all the correct specifications, poured and cored the fuel with all the correct specifications, and used all the proper casing materials, then the only thing left is fuel. And as I mentioned earlier in the video, I really think that I actually cooked the fuel to a higher temperature than 210 degrees Fahrenheit. And that resulted in a harder fuel. And if our testing a while back is correct, harder fuel burns faster than softer fuel. So what would I change? So the instructions told us to turn the wok up to its highest setting. And I think that may have contributed to some of the overheating problem. You see, even if you're stirring the fuel vigorously, you're still measuring the temperature of the fuel with the infrared temperature gun at the top of the fuel where it's coming in contact with air and trying to cool down. But at the bottom, the fuel that's in contact with the metal surface is going to be extremely hot. So I think by the time you read 210 degrees on the top, there's other portions of the fuel at the bottom that are going to be significantly hotter. And to make things worse, when you turn the wok off, it's not going to cool down instantly. It's still going to stay very hot for a very long period of time and continue heating that fuel. So I think if I was going to do this again, I would start by turning the wok to 50% power instead of 100% power. If it has trouble heating that large volume of fuel, you can always turn the wok up just a little bit as needed. The other thing I would change is the target cooking temperature of 210 degrees Fahrenheit. You see, the heating element is built onto the bottom of the wok, so even when you turn it off, the wok is going to stay hot for a very long period of time. So if we turn the wok off around 200 degrees Fahrenheit and continue to stir the fuel for about another minute, the fuel will continue to cook and heat up a little bit while the wok is cooling off, and that should keep us from getting the fuel excessively hot. Well, I hope you enjoyed the video. I spent a lot of time on this project, really a little disappointed with the explosion, but it's part of the process. And I'm definitely going to be back with another build on this motor. We'll try those new tactics for making the fuel and hopefully end up with a much more successful ground test. Thanks for watching. Don't forget to hit that like button. We really appreciate it. We'll see you next time.
Space.